So the first example of more indeterminate forms is the limit as x approaches 0 from the right side of square root of x out natural log of x, which makes 0 times infinity, which is the indeterminate form. So transforming the equation to read limit as x approaches 0 from the right side of the natural log of x over 1 over the square root of x, which then is infinity over infinity, and so then we can use L'Hopital's rule. So by L'Hopital's rule, the limit as x approaches 0 from the right side, taking the derivative of natural log of x, which is 1 over x, derivative of 1 over radical x, which is negative 1/2 x to the negative 3/2. So we have the limit as x approaches 0 from the right of 1 over x times negative 2 x to the 3/2, which by simplifying the problem, we get the limit as x approaches 0 from the right side of negative 2 x to the 1/2, and substituting in the value of 0, we get the answer of 0, so the limit is 0. Next example, I'm going to look at the limit as x approaches 0 of the function 1 minus x to the 1 over x, which when substituting in 0, we get 1 to the infinity, which is of the indeterminate form. So let the function 1 minus x to the 1 over x be f of x. Taking the natural log of f of x, then we have the exponent can move in front, so we have 1 over x, natural log of 1 minus x. So we'll look at the limit as x approaches 0 of 1 over x, natural log of 1 minus x. Which is infinity times 0, which again is an indeterminate form. So just transforming the equation to read the limit as x approaches 0 of the natural log of 1 minus x over x, which is then 0 over 0. So then L'Hopital's rule can apply. So we have the limit as x approaches 0 of the derivative, which is 1 over 1 minus x times the negative 1, and the derivative of x, which is 1. So the limit as x approaches 0 of negative 1 over 1 minus x, which is negative 1. But then remember we use the natural log, so we have to anti-log both sides. So raising to the e, we have e to the negative 1, which is also 1 over e. Next example, we're going to look at the limit as x approaches 0 of sine of x to the x, which is 0 to the 0, which is an indeterminate form. So we're going to let the function f of x equal to sine of x to the x, and then take the natural log of that function. So for the natural log of sine of x to the x, we can move the x into as a coefficient, so we have natural log of sine of x. So we're going to look at the limit as x approaches 0 then of x times the natural log of sine of x, which when substituting in 0, we get 0 times infinity, which is again as of an indeterminate form. So we have the limit as x approaches 0, rewriting to be a natural log of sine of x over 1 over x, which will get us infinity over infinity, so then we can use L'Hopital's rule. So by L'Hopital's rule, we have the limit as x approaches 0. The derivative will be 1 over sine of x times cosine of x over negative x to the negative 2. We have the limit as x approaches 0 of cosine of x over sine of x times negative x squared, which is 0 over 0 again. So we'll have to use L'Hopital's rule again. So we have the limit as x approaches 0 of negative x squared times negative sine x plus cosine of x times negative 2x all over cosine of x. Substituting in the value of 0, we get 0 over 1, which is 0. Then remember we did the natural log of the function, so to undo the natural log, we have to anti-log or raise both sides to the e. So we have e to the 0, which is then 1. So the limit is 1.